Okay, Precalc C. I'm about to assign the back of this worksheet called Proving that a Sequence Has a Limit. So I'm just going to record this video right now and I'll post it, sometime later or whatever. I think this is maybe overkill. I don't know. I did one of these in class together with you. Maybe you found it easy. Maybe you found it overwhelming. You did one for homework. Couldn't really get a read from the class on whether it was easy or hard. But then we went over it today in class. People seemed satisfied. So now we're just going to do one more. You're going to do one more for homework. And in case you get stuck, this is me going over it. Also, this problem is like annoying or something, kind of gross enough that you have to actually do some algebra. You can't just guess. You can't just guess the relationship. Okay, so all right, let's go. This is what I want to prove, so maybe this time I'll just write it out right away. What is it that I am trying to prove? Well, using the epsilon n definition of a limit, what I need to prove is, for all possible epsilon greater than 0, there exists an n greater than 0, such that for all little n, if n is greater than big N, then the nth term of this sequence is between. Okay, well, here I think it's pretty obvious that the limit of the sequence is 5/8. Great. Yeah, because, right, I mean, as n goes, yeah. So, the limit here is 5/8, so this is going to be 5/8 minus epsilon, 5/8 plus epsilon. Okay, great. That's what I need to prove. Maybe before I even wrote that statement, perhaps it was best to do some kind of picture. So what does the nth term of this sequence look like? It's really just a lot more clear if we sort of split this up, right? So if you divide, then it can be seen that the nth term of the sequence just really is 5/8 minus 3 over 8n squared. Okay, in other words, we're always going to be a little bit less than 5/8. I'm not sure I even really want to make a picture, or at least I don't want to make an accurate one. But if that's 5/8, perhaps 3/8 is here, and when I plug in 1, then I will get 5/8 minus 3/8, which is in fact just 2/8, so down here like a fourth. But by the time I plug in, 2 or something, now this is going to be 3 over 32. I don't know. It's going to be closer to 5/8. And as 3 goes on and on, we're going to get closer and closer to 5/8. But we will be always like a little bit less. Okay. So what is my task to prove that this limit is in fact 5/8? Well, what I need to do is, for any possible epsilon challenge whatsoever, no matter how tiny, then what am I supposed to do? Well, this is 5/8 plus epsilon, 5/8 minus epsilon, and I need to show that eventually all the terms of my sequence lie between these parallel lines. And specifically, I need to find a big N such that beyond which this is true. That's exactly what's going on here. I get challenged with an epsilon, I respond with a big N, such that all the terms will land between these parallel lines, past that point. Okay, let's just get right to it. How are we going to do this? With a discovery phase. And the goal of discovery phase is to figure out how far out do I need to go. Okay, well, what I want to be true is that my nth term lands between 5/8 minus epsilon and 5/8 plus epsilon. So let me start with the thing I'm trying to prove and work backwards. What's the nth term? It's 5/8 minus 3 over 8n squared. And I think writing the nth term like that is the thing to do. Because now I can just subtract 5/8 from all three sides, and I get the relatively straightforward inequality that looks like this. Okay, and here's where you have to decide, okay, do I want to use absolute values or do I want to sort of not use absolute values? It really depends on your kind of attitude, your approach to algebra. I think the absolute values are kind of nice. When the terms are alternating, all those positive and negative casework is sort of too annoying. So here, one approach, maybe I'll just kind of do it both ways or something, right? To appeal to both kind of people. It's up to you. So one thing you could do now is you could say, okay, I got this. I see right here that my expression is between negative epsilon and epsilon, which is just another way of saying that the size of it is less than epsilon. I'm calling this like a kind of basic algebraic property of absolute values and inequalities, and that if something is between negative epsilon and epsilon, then the size of it is less than epsilon. Okay, well that's nice because then I can just write this as 3 over 8n squared is less than epsilon. So just killing the negative. Alternatively, you could, what's the alternative? You could ignore the right-hand side and recognize that the fact that let's see. How do I want to put this? It's only this lower half, the region between 5/8 minus epsilon and 5/8 that's relevant. The top half is like totally irrelevant. Therefore, only the part that says negative epsilon is less than negative 3 over 8n squared is like worth talking about. Right? The fact that this negative number is less than epsilon is just a stupid thing to say. Of course this negative number is less than epsilon. Every negative number is less than any positive number. So therefore, focusing only on the left inequality, now I see that I can just multiply both sides by negative 1. Or, if you prefer, just think of it as adding negative 3 over 8n squared to both sides. So that ends up over here, adding epsilon to both sides. Okay, so these are two different ways to reduce this inequality down to this point, whether you want to use absolute values or whether you'd like to sort of think about it more carefully. Anyway, here we go. What am I even doing again? I'm trying to solve for n. So let's do that. I think the thing to do is to reciprocate both sides. Let's do that. So I get 8n squared over 3 is greater than 1 over epsilon. And now let me multiply both sides by 3/8, and I got that n squared is greater than 3, what did I say, 3/8? 3 over 8 epsilon. Okay, so here we see, because this formula is more annoying, we get a quite more annoying algebraic fact about n. And the answer is that n's got to be bigger than the square root of 3 over 8 epsilon. And now, here's what I should be thinking. I should be thinking, this is what I want to be true, and I've just determined by a sequence of algebra moves that that will be true when little n is bigger than the square root of 3 over 8 epsilon. So you give me a tiny, tiny number epsilon. I now multiply that tiny, tiny number by 8, so it gets a little bit bigger. Reciprocate it, so now it becomes a huge number. Multiply it by 3, so now it's, pretty big, pretty huge. Take the square root of it, now it's less huge. That represents how far out I need to go. And so the entire conclusion of the discovery phase is that I should set my big N to be the square root of 3 over 8 epsilon. And unlike the previous problems we've done, you couldn't have just guessed this formula, I think, because it's just complicated. So the goal of discovery phase is to sort of to figure out, to discover this formula, and that's exactly what we've done. Okay, now the actual proof, assuming you've picked your big N well, then the actual proof should be easy, or something like that. So let's do the actual proof. What am I supposed to be proving again? I receive an epsilon challenge. So take arbitrary epsilon greater than 0. So I just kind of accept a generic challenge. of some number, epsilon, which I think of as being very, very tiny. And my immediate retort is the not totally obvious retort of, okay, you give me a tiny epsilon, I'm going to go out to the square root of 3 over 8 times that tiny, tiny number. And the tinier that number is, the bigger that denominator is going to be. The tinier epsilon is, the tinier that denominator, 8 epsilon, will be, the bigger that fraction will be, and the bigger that square root of that fraction will be. So yeah, the smaller the epsilon, the bigger n is. All right, now I just need to show that I picked it correctly. In other words, what I need to show is that beyond this point, all the terms of my sequence are between 5/8 minus epsilon and 5/8 plus epsilon. Okay, so I'll maybe put a little blue box or something around this conditional, because that's my conditional that I need to prove. How do I prove this conditional? Well, I will go past that point. So let's just kind of like take an n which is beyond big N. And now what I need to show about this little n is that by the time I get out that far, the nth term of my sequence is between 5/8 minus epsilon and 5/8 plus epsilon. Okay, let's go. Well, I've chosen my big N very, very carefully, so that big N is in fact defined to be 3 over 8 times whatever the tiny number you challenged me with. And now, I use my discovery phase as a guide for how to work backwards. So, well, square both sides seems like the thing to do. So I get n squared is greater than 3 over 8 epsilon. Now maybe multiply both sides by 8/3. So I get 8n squared over 3 is greater than 1 over epsilon. Now, reciprocate both sides. So I get 3 over 8n squared is less than epsilon. And now I find myself kind of here. So I guess similar to the two different ways of thinking about what happened in the discovery phase, using absolute values or not, I suppose we have sort of the same problem again, right? One thing you might do here is use absolute values. And so if you use absolute values, then you would have to take the sort of awkward step now of rewriting this. Again, I'm going to show this happening in both ways, not to confuse people, but one thing you could do is you could rewrite this as negative 3 over 8n squared. Absolute value of that is less than epsilon. That's obviously a legitimate thing to do because the absolute value of negative 3 over 8n squared just is 3 over 8n squared. So this certainly follows. And then you can use this sort of property of absolute values and inequalities to say, okay, well, if the size of something is less than epsilon, then it must be that thing, negative 3 over 8n squared, is between negative epsilon and epsilon. And that's kind of what I wanted, because now all I have to do is add 5/8 to all three sides, and, well, there it is. And that's exactly what I wanted to prove. If you find it kind of obscure to be using absolute values in this situation, as I think I do, you could instead do the following. Subtract epsilon from both sides, and subtract 3 over 8n squared from both sides. That gives you negative epsilon is less than negative 3 over 8n squared. Okay? Now, combine that with the obvious fact that negative 3 over 8n squared is less than epsilon, because any negative number is going to be less than epsilon, because epsilon is positive. And that is an alternative way of getting to this point. Because if you have negative epsilon is less than negative 3 over 8n squared, and negative 3 over 8n squared is less than epsilon, then you just put those together. So okay, I've shown you two different, minor variants of handling this kind of little technical challenge. But either way, the big picture is we sort of did what we needed to do, and hopefully that helps. All right, goodbye.